All right, welcome back to Calc 2. We are looking at probability, and we are going to look at problem number 3A here, 5A. So it says the clotting time of blood is a random variable t with values from 1 to 20 seconds. Probability density function is defined by B of t is equal to 1 over t times 1 over natural log 20. Determine the probability that the clotting time is between 1 to 5 seconds. Probability is greater than 10 seconds, and what is the expected time for the blood to clot? So let's go ahead and deal with that. So what we have here is B of t here. So I'm just going to write down the problem. B of t is equal to 1 over t times ln 20. We want to know what's the probability that it's between 1 and 5 seconds. 2 is going to be probability that t is greater than 5 seconds, or greater than 10 seconds rather. And then 3 is going to be the expected time for the blood to clot. Okay, and we also have to realize that t has a domain of 1 through 20. Okay, so that'll be nice. Okay, so the first problem here, we're just going to get the probability that's between 1 and 5. Probability is an area under a curve, okay, for continuous distribution. So we're just going to integrate 1 through 5, 1 over t times ln 20 dt as such. ln 20 is a constant, so we're going to go ahead and move that outside of the integral. So that's 1 over ln 20. Integrate from 1 to 5 of 1 over t dt. So that's a pretty straightforward integral at this point. So this is 1 over ln 20 times ln of t. We're going from 1 through 5. We'll just go ahead and plug that in. So we have natural log of 5 minus ln of 1. Conveniently, the natural log of 1 is going to be 0. So we're just going to end up with ln 5 over ln 20. And that's going to be our answer for the first part of this thing. For part 2, okay, we have to go for greater than 10. Okay. However, this is the thing to remember. Like, it only goes up until 20 seconds. Like, that's where all this function is defined. So after 20, function goes to 0. So we are going to go from 10 to 20 of 1 over ln 20, 1 over t here, dt. So all we're going to do is pretty much the same idea. We're going to scoop the ln 20 outside the integral. We have 10 through 20 of 1 over t dt. And again, natural log. So 1 over ln 20 times ln of t. And we're going from 10 to 20. So we're just going to say this is ln of 20 minus ln of 10, all divided by ln 20. So this is going to be, we'll make this a little bit neater. So we're just going to say this is ln 20 over ln 20 minus ln 10 over ln 20. And all we can say that this is 1 minus ln 10 over ln 20. And I would call that good as a numerical answer. Okay, grab the calculator and calculate that out real fast if you'd like to, but that's what we're going to do. Okay, so let's see here. Number 3 was the expected time for the blood to clot. Expected time. So the formula for expected value is t times f of t over its domain, so 1 to 20. Okay. So we're going to go ahead and say that this is going to be t times f of t. This is 1 over t times ln 20, 1 to 20. Well, this is convenient, isn't it? That these guys cancel, and we just end up with a 1 over ln 20 times the integral of dt from 1 to 20. So this is just going to be 1 over ln 20 times t from 1 to 20, and we'll just plug those in. So we're just going to get 1 over ln 20, and then we have 20 minus 1. So we have 19 over natural log of 20. And let's see if we can go ahead and get my calculator out to double check to see if that seems reasonable. So we have 19 divided by the natural log of 20. Here's my ln, there it is. Okay, so if I can see this, so my expected value looks like it's about 6.3 seconds ish seconds. So the expected time for blood to clot is going to be about 6.3 seconds. So I don't know what that means. If it takes you longer, if it takes shorter, I don't know. But I would expect blood to start clotting after about 6 seconds. Okay. And that's pretty much the story of how you do those. So thank you very much for watching, and I will see you in the next video.